Wonderful. Thank you all for being in person and on this wonderful farm at this event. I would love to be there with you and get that glass award myself. Thank you so much, Plug and Play, and thank you for the corporate sponsors and partners of this program. We only, joined the program because we were passionate about collaboration, and I believe we were able to achieve some progress on that. But today, in addition to the presentation that you might have seen earlier today, I would like to give you a brief overview of the business, but actually to talk about some of the interesting components that everyone might be talking about, but not really distilling for you to understand. So FluroSat is a business that has been founded, I founded it in 2016 in November. And since then, we've grown to monitor and manage fields to support crop advisors in managing the fields in 14 countries. And it's been a really rewarding journey of figuring out what does the precision ag adoption looks like and how to make it scalable. So we're just doing it with 26 staff at the moment. As was mentioned in my previous presentation earlier today, we became one of the Microsoft's first AgTech startups as an investee of their venture arm. We have won a number of industry awards in technology, and I can say we're proud of what we achieved. We still haven't changed the world of precision ag, so there's a lot more work out there for us. I would like to briefly introduce you to the team that's behind it, because I'm speaking to you on their behalf. We have a number of agronomists, agricultural scientists, remote sensing scientists. These are the people who deal with satellite imagery, etc., as well as sensor data. And as a team, we think that what we offer to the market is a more scalable and sustainable way of adopting precision agriculture throughout the supply chain. Some of our customers include big names in food processing, in agriculture, input production, manufacturing, and retail, in seed production, and many of them, I believe, is household names for our agricultural community. I would like to tell you a little bit about what our platform does, because I think it's a really fundamental piece to understand the data that I'll be talking about and the value that we build. So we've solved one of the pretty existential challenges of getting all this data from the disparate data sources into not just one place. It's not so much that we're an integrator of data. We can communicate with many different systems, with Climate Field View, John Deere, and any other farm management system out there of major importance. What we then do is we transform the data that usually the crop advisor and the grower put into those systems, saying, I'm planning on planting this much over here, and I would like to get a benefit of having my crop monitored in a remote sensing way, and I would like to have access to objective, scientifically derived nitrogen recommendations, for example. So to achieve that, we partner with a lot of universities. Recently announced our collaboration with Iowa State University. We also are an investee company of Australian Science Agency, so we have lots of different connections through their international network where we source IP. So we don't say that we build the greatest science. This greatest science has been built they started to build it 20, 30 years ago. But what we pride ourselves in is we build the systems and the workflows that make it scalable. What does it produce? It actually produces something that's fairly scalable to consume as well. So we produce shapefiles of recommendations, email reports on the crop status and performance, detection of crop stress around the field, or scouting maps. And this has been really successful. This year has been our big commercial year in the US, and we had a number of customers all the way up to North Dakota. No one, I think, in North Dakota specifically, but throughout the upper Midwest, really getting benefit from the tools we give. And so I would like to show you how it works for a human who operates with it. So as I mentioned, the data such as soil data, weather data, farm management data, with growers' permission, and the consultant enables it, goes into our, and the scientific models of our partners, we predict the state of the crop. So you can imagine it's basically a digital twin of the crop, and it's a tag that is used a lot, but effectively it's a full simulation that allows you to say, okay, well, what's the growth stage? What's the biomass level? How much nutrient, how much water does it require? We surface this information to consultants, to crop advisors. We also use remote sensing to actually interpret what we're getting from satellite imagery or from drones to understand what does it change for us in the model. Are we off because we selected the wrong soil type? Are we wrong because we have predicted more rain and it was less rain? Are we wrong because we're working on the assumption of the wrong hybrid? All of these things, as you know, matter. What matters the most actually is the user feedback that we've built our system to listen to the crop consultant, to listen to the agronomist. And we believe that by enabling them to talk to the grower using the data-driven insights, we are going to enable the data-driven agronomy. And luckily, we haven't just built it in a way that's out of the blue. It's a structured process that follows the crop timeline, where in the beginning, we're monitoring emergence and of course senescence with our crop performance product. So it literally means that you use weather data and satellite imagery, optical and radar, as Ranveer Chandra from Microsoft, who's also one of our mentors and advisors, has suggested that you can turn this data into biophysical parameters of the crop that you can really help agronomists understand which of the farmers' fields are struggling the most, or out of all of the producers, who needs to talk to in the first place. I will also say that there's crop stress detection. Obviously, nutrition is our key, but we've recently released something that people have loved a lot, is the end of season report. So how have you done versus what you expected, and what have we learned compared to last year? It's benchmarking, it's identifying opportunities on your farm. This is quite exciting. The most important piece, I would say, is the ability to actually go into this process fairly simply by just supplying the information that normally every farm already has through the partner integrations, as I mentioned. And I will actually skip a few slides, but I will dive into, the aspects of value proposition validation that we had. So for example, we've successfully helped farmers in Nebraska and in Kansas fix their pivots early in season, identifying the nozzle clogging. We've successfully helped address nutrition deficiencies in some of the fields where it was not noticed in season, but they really could address that between the seasons. Then recently, with the derecho storms and all the kind of stress that's been happening, we have really supported the crop damage assessment. We actually have our head of business development is running a webinar tomorrow morning, 8 a.m. CT on it. You can look it up. But this is actually South Dakota fields with green snap from last year. And we were helping to identify the amount of damage. It's automatic. So this is produced to you by the platform. It detects that crop's been damaged. And that there's a certain area that you can then say is not going to rebound, or it's going to rebound. So the data really helps you get that insurance claim as well. And finally, nitrogen piece, whether you are aiming for the improved efficiency of your nitrogen fertilizer, or you're aiming for higher productivity, depending on the rain, depending on the financials, the model takes that into account and gives you the possibility to discuss this as an advisor with your grower, or as a grower with your advisor, on what you would like to do. And there's been some really successful cases of redistribution of fertilizer to actually feed the hungry crops and not to overfeed the crops that cannot adopt it. I would like to jump into something that I think will be quite interesting for you to know about, and it's the frontier at which we are working. So Continuum Ag, Mitchell, 2 presentations ago, talked about, what are we going to do about sustainability and how all this data is going to help the producer capture some of the value they're creating. And what Continuum is doing is pretty complementary to what we're trying to achieve, and I would like you to get acquainted with this as well. So here we had a case where a large food processor asked us about, here's this random polygon in the middle of a continent you've never seen crops on before. Please tell me what crops are growing there. Is there a rotation practice? Is there a tillage practice there that is verifiable? Is there something that we can support as farmers? We have corporate commitment to sourcing from a generative agriculture acres. And we would like to make sure that this is a kind of farm that allows us to do that. Actually, the bunch of graphs on the screen mean that by analyzing the crop growth over time from satellite imagery, you can really get a good understanding of what crop type was grown. And many companies do that. But the unique part about what we do, we actually understand, did it have too much fertilizer? Did it have not enough fertilizer? Did it have the right tillage practices that were followed? And did it long-term pan out for these growers? So I think this is pretty fundamental piece to understand in enablement of the sustainability payouts and participating in the value capture for the producer. We really need to make sure that the verification piece of the sustainability practices is scalable, and because this is where the bottleneck currently sits, not with the consumer who's ready to pay, not with the producer who's interested in adopting, whether if they can see the dollar coming back to them. We need to make sure that in this market, 60–70% of dollars do come back to the consumer and not to any of the providers who are clipping the ticket on the way. The only way to make that scalable system work is to build the systems that operate with a minimal amount of manpower. This is an example of, for example, for potato producers, it's really important to understand that the fields they're going to be leasing next year have not been in potatoes because, as Kelly just mentioned, you know, potato country, big producing country, when you're in a situation when you cannot put the same crop in the same field every year, and you are needing that information to rely on because it's going to underpin your production, this is something that you can rely on in terms of the remote sensing and imagery products. Our latest product analytics that we produced and a couple of partnerships we announced has really been around identifying tillage practices and crop cover take. And we're actively participating in a number of discussions on helping facilitate the creation of this carbon and sustainability market. And we have some very successful deployments with our customers in New Zealand that are pioneering this space. I'm not going to go into too much detail on this. You obviously get the idea that if the company helps agronomists and growers improve the field level, sub-field level management, and if the growers and agronomists allow this data to fall, to be aggregated and offered to their grain processor that ultimately offers it to the consumer, this is a great thing for them to be to really take participation in that ecosystem market. And with that, I would like to leave you, and please reach out if you have any ideas around the collaborations we can work on together. Thank you.